Sevens and eights. I hope you guys have had a good week and you're loving the fact that it's finally Friday and we're getting into the weekend. And after this weekend, there's only 2 more weeks of school left, which is absolutely amazing. All right, so today we are continuing on with our probability. So in our last class, we talked about listing all the possible options of this given scenario. Today we're going to kind of continue along a similar path. However, this is where it gets a little bit more deeper into probability and different options. So for now, let's start off with our review. So one of the questions you had was the different outcomes if you are bowling and you have 10 bowling pins, keeping in mind that not hitting any pins is also an option. So how many pins what are the different possible outcomes and how many pins can you take down? Well, I could take out 0 and have one go in the gutter. I could take out only 1 pin, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So I have 11 different options, including the 0, of how many pins I could take down in one given option of bowling. All right, so I'm not going to go into too much depth with this review just because I looked at the what you guys handed in and what the work I got was. I think it was like 95% of you got everything perfect. So it wasn't terribly difficult. Today we are going into something that's a little bit more in depth. So let me pose this question to you. What are the odds of correctly calling out a coin 5 times in a row? And what I mean by calling out a coin is correctly calling out heads or tails 5 times in a row. Well, on the face of it, it sounds pretty simple. A coin only has 2 options, heads or tails, so you have a 50-50 shot. Doing it 5 times in a row still doesn't sound too difficult. It doesn't sound like that it would be all that hard to do. All right, let me put it to you this way. So normally in class, I would do an activity very similar to this. However, I don't have that option this year. We used to play a game, and this is with another teacher I used to work with, where you had a deck of cards. You had to correctly call out red or black. As many of you may know, deck of cards, half of them are red, half of them are black color. If you call it out 5 times in a row correctly, he would get you a McDonald's Big Mac meal. You might think, wow, he must have had to buy a bunch of Big Mac meals because it doesn't sound too difficult. You only have 2 options every time you pick. But here's the thing. I'm going to illustrate with a probability tree, the difficulty of getting that. So we're going to illustrate with a coin, heads or tails. Those are your 2 options. So my first coin, what are my 2 different options that I could land on? I could either land on heads or I could land on tails. 50-50. So let's say my first coin I land on heads. What's my option for the second coin? I could either land on heads or I could land on tails. So if I land on heads the first time, second coin I could land on heads or I could land on tails. Or let's say I land on tails. I could either land on heads the next time or I could land on tails. Third coin, I could either land on heads or I could land on tails. Heads or tails. Heads or tails. Heads or tails. So what I'm actually going to do here is I'm going to pause this video for a sec and I'm going to fill out the rest of this chart because it does take a little bit of time. And I will illustrate my point of the difficulty of calling out a coin correctly 5 times in a row. All right, what was 2 seconds for you guys was about 10 minutes for me. So here's the different pathways of hitting coin 5 times in a row. Let me show you what I mean. So let's say I do the experiment, and here are the different outcomes I got. It was heads, tails, tails, heads, heads. Let's say I do the experiment, I flip 5 coins, and this is the result. How many different options, or what is the percentage or the fraction of getting that correct, of calling it out correctly beforehand? Let me show you. First coin is heads. All right, there's only one option from there. From heads, we can go to tails. So from this one, I stem out to where tails is. Reason being is because I can't just stem off to find another tails over here. Okay, it has to correctly follow this sequence, as in this pattern. It was heads, tails, tails, heads, tails, heads, heads. Sorry, heads, heads. All right, my third coin, I call out tails. So from this tails, I have to go to the next tail. So I follow that branch to here, to tails. Fourth coin, heads. From this one, I have to correctly follow to heads. Then my last coin is heads, so I followed it out to heads. There's only one path that follows this exact sequence in order, and that's this one here that we circled. Why is this? Because if I follow this path, if I try to find any other path here that follows that same one, there isn't one. There's only that one. Okay? Because in order to do this, I have to correctly call it out 5 times in a row. That means what I called out in my previous turn matters, because let's say I get the first 3 right, but then the 4th one, I get it wrong. The entire game is up. Okay? It has to be correct 5 times in a row without fault. So what are the odds of me getting the coin correct 5 times in a row? We have to look under this column here for 5 and look at how many different options there are. As you can see, it gets really crowded very easily. But out of all these options, there's 32 listed options here. So that means to correctly call out a coin 5 times in a row, you have a 1 in 32 chance. What are the odds of getting that? Well, as you guys remember, doing decimals and percents. So 1 out of 32, you do 1 divided by 32, your numerator divided by your denominator, to get 0.03 rounded. Then you times that by 100, which gives us 3.125. I'm just going to call it 3%. Rounded. That means you only have a 3% chance of calling out those coins correctly. So this goes back to my story of getting a Big Mac meal. You'd think I'd have to get a lot of Big Mac meals playing this game. No, I'd probably have to get 1, maybe 2 per class. All right, out of 105 grade 7, 8 students, I'd probably only need to get maybe 4 Big Mac meals at total. So this goes to show how odds like this, you think it's very simple, calling it out 5 times in a row. But it's actually very difficult because there's only ever one path that follows that sequence. Let's say your results were all heads. So heads, 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 and heads. Let's say you flip a coin 5 times and that's what ends up happening. How many different options are there to get heads 5 times in a row? Well, you go to your first coin, heads, second one, heads, and the third one. You have to follow it along, heads, heads, and heads. Again, it's only a 1 in 32 chance. All right, so that's about calling it out in order. There's another way that these probability trees can be used. Let's say Chipotle is offering a deal that has a prefix menu. They let you choose either from your tortillas, you can either choose a white or a black or a brown tortilla. For your protein, you can either choose tofu, chicken, or steak. Your salsa, you can either choose mild or spicy, and your toppings, you can either choose guacamole or sour cream. How many different options would you have in total? So I already created this diagram ahead of time. So as you can see, here's your different tortilla options, white or brown. Let's say you choose white. Then you have protein. You can either choose tofu, chicken, or steak. Let's say I chose the tofu chicken. Salsa, I can either choose mild or spicy. I choose spicy. Then I have my topping, guacamole or sour cream. Let's say I choose sour cream. There's only that option to choose that in order, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different options when you are given the choice of white or brown tortilla, tofu chicken or steak, mild or spicy salsa, guacamole or sour cream. It sounds pretty simple because you only have 2 options for each category, but in reality, there's 16 different options. Now imagine if you had 3 options for each category. So you could choose a white tortilla, brown tortilla, or bowl. Then you could choose one of 3 different types of protein, one of 3 different types of salsa, one of 3 different types of toppings. It gets even more. And then you can go further and have 4 different choices for each one. All right, so what these trees go to show is either, let's say, the odds of picking something correctly, like flipping a coin 5 times in a row, or when given simple options of one or the other for each category, how many different options you're left to choose from. All right, so your homework for today is actually not going to be available in the Google form, just because there's no way to do a probability tree on a Google form. However, what's nice about this is the worksheets I have for you are trees that are already kind of pre-drawn out. You just have to fill in the blanks. You just have to fill in the boxes for them to illustrate the odds of different things or the different options you have. All right, so it's not going to get super crazy crowded like this one was here. They're just going to be already prearranged neatly in boxes, which is nice. So I'm not looking at sheets that are crazy, super crowded, because it's very difficult to make those neat. All right, so that's what you're going to be doing today. If you have any questions whatsoever, let me know. But basically what the sheet will do, it will show you something very similar to the outcome of this Chipotle problem. It'll tell you for a sandwich, you have one of 2 different types of bread. You have one of 2 different types of protein, one of 2 different types of cheeses, one of 2 different types of veggies, something like that. And what you're doing is showing the different options or the different possible outcomes of that scenario. All right. I hope you guys have a fantastic weekend. You enjoy it. We only have 2 more weeks of school, which is absolutely crazy. It's been such a crazy year, but we're almost there, guys. We're almost there. So enjoy your weekend. Let me know if you have any questions, and I'll see you guys on Monday.